Hello student, in today's session I will discuss about application of interrupt, what is seam and rim instruction. At the end of the class you will be able to understand what is interrupt, classification of interrupt, seam and rim instruction. Now let's start from interrupt. What is interrupt? Interrupt is a process where an external device can get the attention of the microprocessor. The process starts from the I/O devices. The process is asynchronous. Any kind of external or internal disturbance as input when some process is executing or running. That means interrupt is a signal generated by the external device to request the microprocessor to perform a task. An interrupt is considered to be an emergency signal that may be serviced. The microprocessor may respond to it as soon as possible. The process starts from the I/O devices and the process is synchronous. This one is the peripheral devices or I/O devices requested to the microprocessor to perform the task through the interrupt signal. Interrupt process. The 8085 microprocessor interrupt process is controlled by interrupt enable flip-flop, which is internal to the processor and can be set or reset by using software instruction. If the flip-flop is enabled and input to the interrupt signal INTR pin number 10, we have already discussed in pin diagram, goes high, microprocessor is interrupted. That means interrupt controller will issue an interrupt to the CPU, microprocessor or CPU, to indicate that now it is time to get attention from the CPU. This one is the I/O devices or peripheral devices. CPU will act with initiate the process again the request interrupt generated. This is the peripheral devices. Request is the microprocessor to perform another operation. When peripheral devices interrupted the microprocessor to perform another operation, at that time microprocessor responses according to the interrupt or according to the priority interrupt in which the request is received. Interrupt is 4 times: INT, RST 7.5, 5.6.5, 5.5 and INTR. After receiving request, microprocessor informed to the peripheral devices through the INTA bar signal. The interrupt process should be enabled by writing the instruction EI in the main program. The EI is instruction EI set the interrupt enable flip-flop. The instruction DI reset the flip-flop and disable the interrupt process. Now what is EI? This is 1 byte instruction. This instruction set the interrupt enable flip-flop and enable the interrupt process. What is EI? EI is the enable interrupt. The interrupt enable flip-flop is set and all interrupts are enabled following the execution of next instruction followed by the EI or enable interrupts. In enable interrupt, no flags are affected after a system reset. The interrupt enable flip-flop is reset, thus disabling the interrupt. This instruction is necessary to enable the interrupts again except the trap. Now what is DI? DI is also 1 byte instruction. The instruction reset the interrupt, enable flip-flop and disable the interrupt process. That means this instruction is used to reset the value of enable flip-flop, hence disabling all the interrupts, and no flags are affected by this instruction. Classification of interrupt. In microprocessor there is two type of interrupt, that is hardware interrupt or software interrupt. Software interrupt is of a type, that is starting from RST0 to RST7, or in hardware interrupt classified into two type, maskable or non-maskable. Maskable can be delay or rejected. Non-maskable can be rejected or delayed. Interrupt can also be classified into two types, that is vector interrupt or non-vector interrupt. Vector interrupt is the address of the service routine is hardwired, and in non-vector interrupt the address of the service routine needs to be supplied externally by the device. 5 types of interrupt, that is INTR, RST 5.5, RST 6.5, RST 7.5 and trap. According to the priority, trap is the highest priority, then RST 7.5, RST 6.5, RST 5.5 and INTR. All of these trap are vector because they have a particular memory location. Absolute address is calculated by multiplying the RST value with 008H. Vector address of the trap is 0024H. That is calculated by multiplying RST value, means 4.5 into 008. After we will get this 0024H. This is for the trap. And RST 7.5, that is 7.5 is multiplied with the 0008 and we will get 003CH. RST 6.5 is multiplied with the 6.5 with 0008, we will get 0034H. And RST 5.5 is multiplied with the 0008H, we will get the 0002CH. And similarly, all the vector interrupt or vector addresses calculated by multiplying the RST value with 008H. Then the function of the interrupt signal. First start from the trap. The trap is the highest priority, followed by the RST 5.5, 6.5, 7.5 and INTR. But trap has lower priority than the hold used for DMA, non-maskable interrupt. It can't be disabled, used for critical event as power failure and emergency. Means trap is an interrupt signal which has the highest priority. That means it cannot be disturbable or it is not affected by any other input signal. If microprocessor receives any interrupt signal, then microprocessor responds first to the trap signal. RST 7.5, 6.5, 5.5. These are restart input signal. They are also known as vector interrupt or maskable. This signal has the highest priority than INTR. Among these three signals, the priority is 7.5, 6.5 and 5.5. These are maskable, that means they affected by other input signal, or it is maskable interrupt. INTR interrupt. The INTR input is the only non-vector interrupt. It is maskable using enable interrupt or disable interrupt instruction pair. INTR has the lowest priority among all the interrupt, or it is maskable. That means it affected by any other input signal. What is same instruction? Set interrupt mask. Maskable interrupts are enabled under program control with two instructions, that is EI, enable interrupt, and SIM, set interrupt mask. That means it is a multi-purpose instruction which is used to mask the interrupt or make them available. It is also used to transmit serial data through SOD pin. It is used along with the content of accumulator, valid only for RST 7.5, RST 6.5, RST 5.5. This is the D0 bit, D1 bit, D2 bit, D3, D4, D5, D6, and this one is the D7. Bit D02, D0, D1, D2, these are the RST 5.5, 6.5 and 7.5. If it is set to 0, that means it is available. If it is set to 1, that means it is masked. Similarly, bit D3 MSE mask set enable. 0 ignore bits 0 to 2. If it is set to 1, set the mask according to the bit 0 to 2. Similarly, bit number D4 R 7.5 force RST 7.5 flip-flop to reset condition, that is 0. This one is not used. Bit D5 and bit D6 SDE enable serial data. If it is 0, ignore bit D7. If it is set to 1, send bit 7 to the SOD pin. Now this is SDO, serial data out. Now let us discuss about the meaning of all the bits. D0 to D2 indicate interrupt, masked or available. Bit D3 is a control bit over D0 to D2 to make them significant or invalid. D4, it is an extra provision for RST 7.5 to reset it. If it is 1, then control of bit D3 is not on D2. Now bit D6, it is the control bit over D7. D7 serial data to be transmitted through the SOD pin. SIM. It is used as control. Now what is REAM instruction? One interrupt is being served, other interrupt request may occur and remain pending. The 8085 has an additional instruction, that is REAM, sends the pending interrupt. Or REAM means to know the status of interrupt. It is a multi-purpose instruction used to know the status of pending interrupt and also to receive serial data through SID pin. This status of interrupt and serial data is loaded into accumulator after execution of REAM instruction, valid only for SID pin. This is the D0 to D7. Bit D0 to D2 all are either 0 or 1 available or marks. RST M5.5, that means RST 5.5 masks. M6.5 means RST 6.5 masks. M7.5 means RST 7.5 marks. That is set to 0, then available. If it is set to 1, then it is marked. Now bit D3, i.e. interrupt enable, value of the interrupt enable flip-flop. Now bit D4, that is P5.5 RST 7.5 interrupt pending. Similarly bit 5 D5 RST 6.5 interrupt pending. Similarly bit D6 RST 6.5 interrupt pending. Serial data in. Now let us talk about the meaning of bit D0 to D7. First, D0 to D2 indicates interrupt marked or available. Bit D3 indicates interrupt, this one, interrupt enable or disable. Similarly, bit D3 to D6 indicate status of pending interrupt. Now bit D7 is the serial data received through SID pin. Thank you.